Hi there. Well, in this video we're going to look at some specific examples of when limits fail. And if you didn't watch the last video stated generally why they fail. And remember, they can fail in three different instances: if the right and left-handed limits disagree, if the function is unbounded as x reaches a particular c, and then the third one is if we have this oscillating behavior. So we're going to look at those three types of examples in this video. First one is right here. We have a piecewise function, and all the action is happening around 2, so you can look there to see that we're probably going to be interested in the limit as x approaches 2. Okay, so let's go to our calculator, and in our calculator, in the y-editor, you can see here's my piecewise function. In case you didn't know how to enter a piecewise function in your calculator, you simply enter your function value and then multiply it by your constraint. Here's the first constraint, and then you add your second function to it, followed by the other constraint. So I'll just scroll over here so you can see that. So if you didn't know how to enter in piecewise functions in your calculator, now you do. Okay, so you can see the graph right here. Let's go ahead and blow that up. And you can clearly see that right around 2, we're going to have some different limits depending on which side we approach 2. If we approach 2 from the right-hand side, then it looks like my limit is going to be positive 2. But if I approach 2 from the left-hand side, it looks like my limit is negative 2. Okay, if we go to the table, this should confirm that. And if we approach 2 from the left-hand side, 1.9, 1.99, and 1.999, you can see that we're approaching negative 2. And then if we jump to the right-hand side of 2, we get a different number. And it looks like as we approach 2 from the right-hand side, that we're approaching positive 2 in this case. So clearly the left-handed limit, which is right here, it looks like it's negative 2, does not equal the right-handed limit, which equals positive 2. So we would then write in our limit statement here, we would say that it equals, what does it equal? Well, it doesn't equal anything, because the right-handed limits and the left-handed limit don't agree with one another, so we could say does not exist. Now, just a little aside here, you could talk about the left-handed limit, and you could say the limit as x approaches 2 from the left, and that's what that little negative sign means. So this is notation to describe a one-sided limit, and that does exist. That, remember what that was? That was, what was that? Was it negative 2? Yeah, I guess it would be negative 2. And then the right-handed limit, we would say x approaches 2 from the right of f of x is positive 2. But again, since this guy and this guy, even though the one-sided limits exist, they don't agree with one another. Okay, therefore the limit as x approaches 2 in general doesn't exist. Okay, the next example is going to be this one right here. F of x equals 1 over x squared. And if we go to our calculator and we put this up on the graph, let me turn it on first. Turn the piecewise off. Okay, you'll see that everything updates. Okay, my table got updated, my graph got updated. The table's no good because I want to now approach 0. So let me get rid of all these guys. And let's approach 0 from the left, which is negative 0.1, negative 0.01, and negative 0.001. So clearly we're getting closer to 0 from the left-hand side, and you can see that my y value is blowing up. It's getting extremely big. As we get to the other side, it's going to do the same thing. Okay, in fact, we get the same numbers. Well, in this case, it just so happens that the left-handed limit and right-handed limit happen to agree. And because they happen to agree, we can go ahead and write, instead of does not exist, we can go ahead and write positive infinity. Now remember that this is not a number. Okay, we're not saying that this is the bound or the limit of this thing. I guess we are saying it's the limit, but we're more stating how this limit fails. It's not enough to just say, well, it doesn't exist. Now we're stating how it doesn't exist. So just keep in mind that this is not a number. Okay, so the final example, we have this trigonometric function here, cosine of 1 over x, and let's go to the calculator and see how this plays out. Okay, now the good thing about this is we're letting x approach 0, so I don't have to change really anything in my table. What I want to point out though is the graph. When you first look at the graph, it appears that this limit could be approaching -1 down here. But as you get close and zoom in just a little bit, you'll soon find out that there's something else going on here. So I just zoomed in, and now you can see instead of coming down here to -1, we bounce back up, and then it looks like we bounce back down, and then maybe back up again. And if we zoom in yet again, you'll get an even better idea of what's going on. So you could try to trace this thing. You could come to your calculator and hit trace, and then try to. So here's your x value right here. We're to the left of 0, and you can see here's my y value. If I go just to the right of it, you can see this jumped way positive. Okay, well, at 0, this doesn't exist. That actually makes sense. Well, the trace isn't going to help us out too much, but the table, if we just look at the table here, -0.1 gets mapped to this number, and then as we get closer to 0, then we went positive, and as we got closer yet, we got smaller. If we actually come down here and enter in even a smaller number, you'll see that we went from negative to positive to a smaller positive back to a really big negative. So it doesn't look like we're getting close to any particular number. It's just kind of bouncing all around, oscillating back and forth. If we did the same thing on the positive side, we would get similar results. I'll leave that up to you to do because we're running out of time on this video. So we come back to this guy right here, and in this particular instance, the left-handed limit and the right-handed limit didn't even exist. Okay, so there's no sense to talk about a left-handed limit and a right-handed limit. They didn't exist, therefore the limit as x goes to 0 doesn't exist as well. So those are the three basic types of limits that fail to exist. There's others out there that do similar things, but I hope that made sense, and in the next video we'll look at some more examples yet. See you then.